Thank you very much, Gita, and thanks for having me here. Yes, I did mention this topic in Sicily, and I'm not saying APL is old, but this was our venue, and it was an excellent conference, and we enjoyed it very much. So, if any of you were there and can recall that 3 years ago, you may recall that I was rather, on the learning curve, I'd say, very much for this sort of thing, this topic. And my presentation was a little bit jumbled and a little bit disjointed, and I threw in everything I could, but it wasn't really organized very well. And well, let's hope today is different, but we'll see. So I did mention back then that I do this on a regular basis. My day job is a place called BCA Research. We study the global economy, and we use Excel extremely commonly for receiving data from our sources, keeping track of that data, reporting to one another, and having automated tasks report to ourselves, and so on. Charting, statistics, we use it all the time. So it's extremely important, and I'm assuming many of you are in the same boat, perhaps. So what I'm talking about today is the fact that in the mid-00s, Microsoft adopted the what is referred to now as the OOXML, or the XML standard. And so you may recall, file names switched from .xls to .xlsx. And on Wikipedia, they give a little definition of what that standard is, and go on to explain it a bit. But essentially, the key factor is that it is a zipped XML-based format. So it is, every XML file is a zipped archive containing XML, and that's the key point here. And by the way, it applies to PowerPoint and Word as well. So if you go to Microsoft's page about this, they give a long-winded explanation about it, and again, the useful part is the fact that it is zip and it is XML, and you have methods and properties exposed through that. I'm not going to read everything here, but if you can, that's the main Microsoft web page that talks about it. And as it says down here, you can perform complex operations in just a few lines of code. Where have we heard that before? So what about the good old methods, COM and CSV? Well, they're still actually used. We still use them every day ourselves, and I'm gradually attacking that with what I'm learning here. But for the moment, the COM is used for various reasons, and so is CSV. In fact, CSV is very handy for many things, including when you really want to ship something around very quickly and not worry about formatting and stuff like that. But there are issues. COM, as you know, you have to, if you're going to use COM, you have to have Microsoft products on your system. And they have a footprint, as we all know. They chew up resources. There's sometimes performance issues depending on the size. There's automation challenges. That's an especially important one for us. We do a lot of automation, and automating Excel has its challenges. And as I said, CSV is still useful. Now we have quad CSV, which makes it even better. But one thing about CSV is the data type issue. Of course, everything is a character string until you do something with it otherwise. And now with Quad CSV, we do have that the tool to deal with that to some degree. So what is in this zipped archive? It's something like this. You can find various diagrams like this on the web, and essentially it's a series of files, and each one of them pertains to a particular aspect of the spreadsheet. I've outlined the key ones that we'll be looking at today, and some of these will be there or not there depending on the content of the spreadsheet. But you should always have a worksheet, something called shared strings, which is quite important, and styles to a lesser extent is important. especially if you're trying to elucidate data types. And if you have a look, if you expand one of those, if you expand an Excel file, this is what you get. You get a structure like this. So I've done it in a couple of ways, using this command line approach, and if you look in Windows Explorer, you see this. So every expanded Excel file has a folder, has these 3 folders at the top, and inside the Excel folder we have these 5 items, or perhaps more. And usually, or I think always, there's a worksheets folder, subfolder, and then within that we have down here we have several, 1 or more worksheets. So that is the typical target you're looking at, is the actual rectangular array of information called a worksheet, and you may have 1, or you may have 3, you may have several, depending on how you've structured that workbook. And the other important one I mentioned was shared strings. So here it is right here, shared strings and styles. Now we can do this kind of stuff that I'm going to be talking about already, and that's part of what I talked about in Sicily. Syncfusion provides a tool called XLSIO, and it, to be honest, I don't know if it uses the thing I'm going to be talking about, the Microsoft toolkit. But it does do essentially the same work, and so you can address your spreadsheet through methods and properties. A fellow in Canada named Pierre Gilbert built another toolkit on top of that. He calls it SFXL, and it's quite an excellent little toolkit. So I'd recommend this perhaps as a total starting point if you're a total beginner. Pardon me. And he's documented it quite well. He's got some nice APL functions that call the Syncfusion controls. And it works fairly well. And it does have this integration with Dyalog in terms of the data table hookup. So that's a method for for moving large quantities of data in and out of APL, which is nice. So if you Google around and see how people do this, they look in the Visual Studio crowd, C# crowd, you get this kind of code where they basically loop through the bottom level of a spreadsheet content. And so essentially what they're doing is they're looping one cell at a time, if I'm going to call those things cells in the Excel worksheet. And of course we don't like that kind of thing. We do an array approach. So in our case, how are we going to do it? What is our best strategy? The Microsoft SDK offers properties and methods that allow you to grab the entire worksheet, the content of the entire worksheet, as a string, as an XML. It is an XML file after all. And so it is just a vector to us. It's just a tagged vector. And it essentially might look like this on your screen or like this in a browser. So you can probably work your way through that, the fact that there's sheet data, and then there are rows, and then there are C for cells, and inside a cell we have a value. So row, C, value. And there's the value in the visual spreadsheet. So here's the method we use to grab all of that XML content, the outer XML. I'm not sure, method or property. And that may be a large item if your spreadsheet is large. But then we have to parse that, obviously. So here's here's some of the questions you're going to ask yourself, depending on what your application is. There are various ways to go from there. So it depends on what your objectives are. You may have, as we often do, columns of a singular data type. And so if you can structure, and by the way, I'm not going to just give everybody code for doing this. I do have some that works, and I'm still working on it. But I think it's the kind of thing that people might love to tinker with in some cases and tailor to suit our needs. So these are the questions you'd be asking. Am I looking at singular data types? Am I looking at just a focused selection of the worksheet? Am I looking at conditionally choosing things from that worksheet? Do I want the formulas and the other metadata that goes with it? Are are the strings and the data types important to me? Do I want to distinguish those from the numerics? Am I going to do this in a batch way? Am I going to try to streamline things somewhat by grouping things together? And what if it's a very large spreadsheet? What are the issues with that? I'll be talking about some of these things further. So here's my typical routine that I do for processing this sort of thing. I go get the XML for a worksheet, and assuming it fits in the workspace, of course. And then I determine there's a way of determining how many rows and columns the actual Excel worksheet has, so that tells me the shape of my final result. I then create an empty array, basically, of that content, of that size, pardon me, and then there are ways of determining the data type of the individual cells through the tools that we have. We then extract those items from that XML, and at this point it's still all text strings. So then we have to convert to numerics for the numerics or the dates. There are these small error items in Excel, such as hash NA, hash null, and so on. You have to deal with those. And a few other variations. And for the strings, now this is the interesting part, for the strings, the worksheet typically does not contain the strings, it contains pointers to the strings. So the strings are in that shared strings XML file, which is essentially a table, if you can think of it as a 2D or a one-column list of all of the strings that would appear in your spreadsheet. And the reason they've done it that way, of course, is to minimize redundancy. So what we have are indices or pointers to that shared strings table, typically. There's also something called an inline string, which kind of overrides that, and that's where the text would, in fact, be in the worksheet XML. And so those are available, and we have to tease those out and then reassign the cells to their original strings. Because it's XML, it'll have escape sequences in it. We have to deal with those. And then Excel doesn't store for totally empty cells. It stores nothing. So basically, you have to reconstruct or deal with the fact that you may have empty cells. So you're going to have to expand your array to accommodate those, and then fill them in with nulls, perhaps. And then, do your own tests and so on to make sure you've got the right data. So it looks something like this. You have the DLL, which is the Microsoft SDK tool that you get from Microsoft. It's a simple download. And we set that up, and we call the open method to open the file that we're targeting. We open something called the worksheets collection. We figure out how many worksheets we have, and then in a for statement, we go get those items one at a time by their ID name, and then we pull the outer XML, which gives us the entire string, accumulate that for each worksheet, and carry on with the sequence I just went through. Again, conceptually, it's like this. You've got your spreadsheet, you pull out the XML, you pull out the shared strings, and perhaps the style that may or may not be important to you, and then you process those, and you end up with an APL array that looks pretty similar, without, of course, the formatting and the colors and so on. You can strip those out. There's also another option. Because everything is an XML file inside here, we could simply unzip that package. And when you do, it resolves itself into this structure, as I pointed out before. So right away, a quad-n read of that file will give you what you need, essentially, without using the Microsoft SDK, in other words. So there are some pros and cons with doing it that way. Obviously, you set aside a temporary folder, perhaps, or a dedicated folder, and you unzip your file, grab the contents from it, and so on. So it's a two-step process rather than the single step. So you might be asking, which of those is faster? And so I did some tests, and let me just flip to my folder structure here. I did some tests. I've got a folder with some files in it. So what I did was I have I have some sample information called basically a client database of names and addresses and so on. And I didn't exactly replicate it, but I simply expanded it and I randomized things a bit and I turned things around. So I created 10 files, 10 or 11, whatever files with 100 rows, 200 rows, 400, so powers of 2 up to 100,000 plus rows. And I wanted to see performance-wise how those get handled. And ran some tests. And it's something like this. So the numbers in the graph are corresponding. So here's method 1 where we're using the Microsoft SDK. And these are the timings for reading that and turning it into an APL array. And here's the row count and the byte count once it is in the APL array form, quad size. And over here is the zip method. So the zip method, as I said, is a 2-step method. So I'm not counting the unzipping part because I'm thinking if you're in a batch environment, you may be comfortable with doing that step in advance in a background task at night or something like that, and then in the morning do your analysis. So you could potentially get the difference between those two columns out of the way in some other offline process. But as expected, as you might expect, so what I have here is the numbers plotted on a logarithmic x-axis, and then I took the log of the numbers just to show that they are, in fact, it's a linear equation, and you double the number of rows, roughly you double the time. Up to this point, at least. I didn't go too much beyond that. And you can see there's a fractional advantage, I guess, to doing it with the zip method. But again, that's kind of cheating because you're doing a 2-step way there. Perhaps I should demo that now. So I have a, first of all, let me demo the, okay, this is tricky because I can't see my screen. I have a simple reference to an Excel file in one of my folders. And I'm going to read that data. So I'm going to assign, yeah, this is difficult typing. So assign a, okay, is the font okay? Probably should increase it a bit, right? How come it's not increasing? Oh, it is, yeah, right. Okay. So I've got a function that reads that spreadsheet called ssread. And I'm going to assign that to t. I get back a 3-element result. And what is it exactly? Well, basically I've got the worksheet names in column 1. I've got the worksheet contents in column 2. And over to the right, I've got what I call my little data type map. So again, it's a rectangular array, a character array, matching the size of the data itself. And S means string, N means number, blank means blank or null. And there's a few other things that could be in there. So that gives me the content of the spreadsheet, and you'll notice it didn't take any time at all to grab it. Now, in terms of the, whoops. I don't want to spend too much time here because we'll get. I've got basically a looping algorithm that takes those 100, 200, 400 size files, and pulls that information in a loop. And so, if I run that and give it a number, give it how many items. I don't want to go through all of them because it might take more than a minute. But I'll do 5, let's say. And what this does is it goes off and gets the, I'm going to have to reduce the font slightly there, I think. It goes off and gets each spreadsheet, figures out how many rows are in it. The 4th column is the timing, and then I've had a breakdown of the content. How many, what's the name of the worksheet? In this case, it's always sheet 1. What's the range from A1 to whatever? I also look at the shared strings content. How many items are in that shared strings table? How many are unique? That's all given to me by the SDK, so it's just a matter of plugging into that. And again, it looks, if we use quad XML on our original XML, let's go back to that a minute, here's what you get. You get an array with the various cell contents laid out for you. And I found that to be somewhat useful, but only to a point, because, of course, you are expanding the memory required for that object, for that array, by expanding each cell like that. And so once you get into very large spreadsheets, you've got to have a really large workspace to handle that. So I prefer to use my simple seat of the pants method, which is to use epsilon underbar and the partition function to grab each individual item according to, and look at its data type and so on. And I'll get to what data types look like, how we distinguish them in a minute. I also tried Quad S, and again, once you get into large spreadsheets, there are some limitations I found. I'm going to skip through a lot of stuff here to save time. The load text strategy, as you may know, basically quad VFIs everything and sees and decides what is a number versus not to distinguish data type. Quad CSV, you can supply column data type information, otherwise you get strings. And with OOXML, you have tags like this. So T, when you see a T equals S, that means it's a shared string. When you see an E, it's an Excel error item. A B is a Boolean, a F is a formula, and so on. As you know, the letters are fairly intuitive. So we work through the XML with that. And I've outlined exactly a test case scenario here that shows you this is, so we have a row tag to tell us where the row starts. We have a reference, meaning what cell is this data in? S equals 9. It's a string, and as I said, those are pointers, so it's string number 9. Or sorry, style, pardon me. S is style. T equals S is the string, and the value is 27. This is the pointer. So it's shared string number 27 in the table, and it has a style 9, and there's another table for styles. And you can sort of work your way through that. Down here we have an XLNA, looks like this. So we have a T equals E to tell us it's an error item, and we have the value. And in fact, this is a little different. It's a string, but it's not in the shared strings table. It's in the XML worksheet, XML itself. A simple numeric value has no T value type, or it may have a style, but it would simply have a value, and that tells you it's a numeric. Here's the shared string table again. It looks like this, and you have to plug those back into your pointers. So if you have, it gets complex if you have something like this where you have a variety of fonts mixed in. The shared strings table will have individual items within its own division. So SI is the start of a shared string. So we have this piece of text, then we have this piece of text down here and some style information that goes with them. You have some other glitches that you have to deal with, some other edge conditions. Line feed, new line. I'm not going to spend too much time on that. You will have a namespace prefix. Thank you, Andy. A namespace prefix if you use the SDK. You will not have it if you use zip. So that's another issue to deal with. Style information is like this. Don't have time to play. There are some standard styles, and there's some numbers that refer to those. You have to be aware of that. Now, what about very large spreadsheets? There are some issues with that, of course. You have to deal with the fact that the worksheet itself may not fit in your workspace, so you're going to have to break it up into chunks, perhaps. You can use the SDK to do that, I believe. I haven't tried that yet. You can use quad and read, obviously, to bring in parts of it, or you can deal with it outside of the worksheet in chunks some other way. And performance may be an issue with that, so you may want to compare those previous methods I talked about. In terms of automation, we have some issues there, and you still can't get past the fact that if somebody else has the spreadsheet open, the SDK will have trouble dealing with that. So you'll get a message like, cannot access the file that's used. So you have to compare methods to find out which works best for your automation. So to summarize, again, it's a zip collection. We have the two methods of attacking this problem or opening that information and getting it into APL. We have to parse for the data types and the content, and that's all about reading. I haven't accomplished creating a spreadsheet yet with the SDK. I have a workaround though that I think will work, where I take an existing template, repopulate the XML content in the middle of it, and then put that back in the archive, and that seems to work. So I'll be stay tuned for that. I'd like to make an acknowledgement to Dyalog. Thank you very much for your assistance in helping me work this out, especially JD and his help with .NET issues. And of course, my dear friend Daniel was very instrumental in actually explaining many things in his life to me, and including even this process that I'm going through here of learning about Excel and APL. Many of the tools and techniques that he shared with me became very handy in this talk. Thank you.